Okay, go ahead and look at these vocabulary words and fill them in your circle. Okay, the only two new words were this one, secant line. Secant line is a line intersects a circle in exactly 2 points. So that would be this blue line right here, because it intersects the circle here and here. Secant, like second, hits the circle 2 times. So here and here. It goes in and out. Tangent line, a line intersects a circle in only 1 point. So it'd be this red one. So it intersects a circle exactly right here. This is the point of tangency. Radius, the distance from the center to the edge. So from the center to the edge. So this one would be the radius. And chord is any segment inside the circle that has both endpoints on the circle. So it'd be this green one right here. This would be the chord. And then the diameter is the longest chord. It goes through the center. So it would be this orange one. So go ahead and check your answers. Okay, so last week we talked about central angles. A central angle is this angle here with the vertex at the center. So do you remember when the angle, this angle right here, AOB is 45 degrees, the arc, the intercepted arc, this arc right here that it is created, see that right here? That has the same degree measure. So this one was 45 degrees. That's what we learned before spring break, and we took a test over this. Okay, it's always the same degree measure. All right, so now we're going to talk about an inscribed angle. An inscribed angle is any angle that has its vertex on the circle. So see the difference? This one's in the center. For the central angle is in the center. Inscribed angle is on the circle. The main thing about this angle, here's my inscribed angle right here. So let's say that this angle was 30 degrees. The intercepted arc is not the same. It is double. So this intercepted arc would be 30 times 2 would be 60 degrees. The degree measure would be 60 degrees. So see how the angle is half of the intercepted arc. So we're going to practice that. Go ahead and write that down in your notes. Okay, so get some paper. And let's work on these. Look at number 1. It says find the measure of angle BAC. So the measure of, this is how you would say it in words, find the measure of angle BAC, and here it is in our symbols. The measure of angle BAC. And the measure of arc BC. So I know from B, this arc right here, an arc is a piece, like the pizza crust, right? So AB, this arc right here, BA or AB is 100 degrees. This other arc on the other side, AC, is 120 degrees, right? All the way around, 120 degrees. So remember, a circle is 360 degrees. So what would this arc be? So 100 plus 120 plus what gives me 360? Figure that out real quick. Okay, you should have gotten 140 degrees. So this arc here is 140 degrees. So an inscribed angle, so this angle right here is half. So 140 divided by 2. Do that real quick and find the measure of this angle right here, BAC. Okay, good. You should have gotten 70 degrees. 140 divided by 2 is 70. So this angle here is 70 degrees. Going to number 2. It says that the arc, the inscribed arc, intercepted arc is X degrees. The angle, inscribed angle, is 82 degrees. So remember, this is half. So see, the arc is larger. See, the angle is a smaller degree. So the angle is smaller. It's always smaller. So multiply that by times 2, and you would find the arc. Okay, good. You should have done 82, multiply 82 by 2. So 82 times 2 is 164. So this arc right here is 164 degrees. Okay, let's do number 3. It says find the degree measure of arc WV. So I want to find from W to be the degree measure. So remember, the angle is always smaller. So here's my angle. It's smaller. It's half of the intercepted arc. So if this is the angle is 42, the arc is larger, doubled. So go ahead and double 42. 42 times 2 and find arc WV. Okay, so it says the inscribed angle is half the measure. So the angle is always smaller. So my angle is 42. This is half. This is half. So then this would be double. 42 times 2 is 84 degrees. So you should have gotten 84 degrees. Go ahead and do this last one over here. It says find a measure of arc RVQ. So first trace it from R, starts at R, stops at Q, so R, Q, and it passes through V. So RVQ is this that I'm outlining here. So you should draw this or print this out and trace it. So RVQ is this whole thing. So remember, this is half. The angle is smaller, so the angle is half. So I'm going to have to multiply by 2 to give me this length. So go ahead and do 95 times 2. Okay, you should have multiplied 95 times 2 because the angle is smaller. The arc is double. So 95 times 2 is 190 degrees. So the degree measure of arc, RBQ, is equal to 190 degrees. 190 degrees because it is double the angle. Let me know if you have any questions, please. Okay, go ahead and try number 5. It says given arc, the measure of arc AC is 52 degrees. So from A to C, so I would draw the circle on your paper, then trace arc AC, and then I would write it's 52 degrees out here because the arc is 52 degrees. And remember, the angle is half, right? Remember, the arc degree is more than the angle degree, so the arc degree is more. The angle is less. So I'm going to divide 52 divided by 2 to find the measure of the angle. Go ahead and try that. So 52 divided by 2 would give you the angle here. Go ahead and find that. Okay, you should have gotten 26. What you need to remember is that the angle is always going to be a smaller degree than the arc, the degree of the arc measure. Go ahead and try number 6. Given the inscribed angle measures 82 degrees, so this is the inscribed angle is 82. Find the degree measure of the intercepted arc. So I want to find the degree measure of this arc here. Remember, the angle is smaller. The arc is twice as big, so find this by multiplying the angle by 2. So I'm going to trace the intercepted arc. That's this arc right here. So you should have done 82 times 2, and you should have gotten 164. So the measure of this arc is 164 degrees. 164 degrees. Go ahead and try number 7. Find the measure of angle ABC. Or you would write it like this, the measure of angle ABC. So I need to find ABC, this angle right here. So what is the measure of this angle? Remember, the angle is smaller. The arc is larger. So either multiply or divide. So they gave me the larger one. They gave me the degree measure of arc AC is 44. So am I going to multiply or divide to find the smaller, the angle measure? Okay, good. You're going to divide. So 44 divided by 2 is 22 degrees. So the angle is 22. Try number 8. It says find the measure of angle 1, which is this one here, the inscribed angle. Find the measure of angle 2. Angle 2 is the central angle. So remember, the central angle is the same, and the inscribed angle is half, right? Smaller. Okay, good. You should have got that this angle here, angle ATM, oh, let me put an M right here, is 58 degrees because angle ATM is a central angle. It's the same as the arc measure. And angle AVM is half of 58. So angle AVM is half of the intercepted arc, which is 58. So half of 58 is 29 degrees. So good. So to recap what we learned the inscribed angle, this angle right here, is half the arc. So half of 44 is 22. That's it. You just have to divide by 2, or you multiply by 2 if you need to find the arc measure. Okay, so think about this for about 2 minutes. What is the difference between a central angle and an inscribed angle? Explain to your friend or write down the difference in 2 sentences on your notes. Okay, then draw 1 or 2 circles. Just trace them from any bottle cap or anything you have at your house. Draw both the inscribed and a central angle. Write the correct measures. Pick any number you want. Like I made up the other problems, so just make some problems up. Go ahead and just try it, please. Okay, the main difference is that a central angle is at the center. The vertex is at the center, and it's the same. So this would be 58 degrees. And an inscribed angle has the vertex on the circle. See that? It's on the circle, and it's half. It's smaller. It's half. So it would be 58 divided by 2. So it would be half the size of the inscribed. That inscribed angle is half the size of the intercepted arc. Okay, we're going to talk about circle and angle relationships. So angles created outside the circle. So secant and tangent lines can meet outside the circle. See how these two lines go through the circle and they meet outside the circle. They intersect right here outside the circle. And they form an angle. So they formed this angle. Angle CAT is formed. All right, so how do I find the measure of this angle? It's kind of easy. All you do is you find the intercepted arcs. So to find the intercepted arcs, you shade in the angle. So I'm going to shade in this angle. You don't have to do this all the time, just for this first one. I'm going to shade in this angle right here. And see the 2 arcs that were intercepted? This arc here and this arc here. Not this one, just these 2. So all I'm going to do is subtract them. I'm going to write down the big intercepted arc, which is 76. I'm going to write the 76 minus the smaller one. The smaller one is 20 degrees. So 76 degrees minus 20 degrees, and then I'm going to divide by 2. So divide it by 2. That's it. That's the theorem. You just subtract them, the big one, 76 degrees minus 20, find that answer, and then divide by 2. Go ahead and try that. Subtract them, then divide by 2 and find your angle measure. So 76 minus 20 degrees is 56 degrees. Divided by 2 is 28. So the measure of this angle that was created by these 2 secants intersecting outside the circle is 28 degrees. That's all you have to do. So let's try this one. Okay. I think the hardest part is finding which arc measure, because I have this one is 59 degrees and from BE is 35 degrees, but then I also have DE, which is 166 degrees. Which ones do I use? Well, the ones that are intercepted by this angle. So an easier way to do that would be to just shade in your angle, right? And then the arcs that you color in, see these 2? So I'm coloring in 35 and 59, not 166. So those are the ones that I would use. So then you do the big intercepted arc minus the small one. So the large one is 135. So I would do 135 minus 59. And then you divide by 2. Go ahead and try that. Okay, 135 degrees minus 59 degrees is 76 degrees. Then divide by 2, so you should have gotten 38 degrees for the measure of angle BCD. 38 degrees. So again, all you do is you find the two arcs and then subtract the big one minus the small one. And then you divide by 2. Okay, try number 11. If you trace it, you would find that these are the arcs you need. 160 minus 60 divided by 2. Please write this down on your paper. Don't just plug it into your calculator. That way you can remember. So write it down on your paper for your notes. Okay, 160 minus 60 degrees is 100 degrees. Divided by 2 is 50 degrees. So the measure of this angle right here is 50 degrees. Go ahead and try number 12. So if I trace it, these are the two arcs that are intercepted. 61 degrees and 173. Look at your formula right here. Use your notes. So the big arc minus the small arc is 112 degrees. Divided by 2 is 56 degrees. So the measure of angle WVT is 56 degrees. Try number 13. Okay, good. To find the angle that is created outside the circle, you would find the large intercepted arc minus the smaller intercepted arc. Subtract them, then divide by 2. So you should have gotten 46 degrees as your final angle measure. Good job. So what we learned was when you have two lines, well, these are two secants, right, intersecting outside. This was a tangent and a secant intersecting outside. So whenever you have two lines intersecting outside the circle and they make an angle, right? They create an angle. The angle created, to find the measure of the angle, just subtract the larger arc minus the smaller arc, intercepted arcs. Not these over here, the ones that are inside the angle, right? If you have a hard time seeing that, you can always shade it in. See, shade in inside. So it would be, you can easily see it's 155 and 63 degrees. And you would subtract them and then divide by 2. So we're going to learn one more angle type. Okay, so for 2 minutes, you're just going to draw what we just talked about. So draw a circle with two secant lines. So a circle just with two lines going in and out, and have them intersect outside the circle. And then make up your own arc measures and find the angle measure. How do you find the measure of an angle using the intercepted arcs? That's what we just learned. Okay, last thing for today. Okay, we're going to talk about angles created inside the circle. So we just did outside the circle. Now we're going to do inside the circle. So notice I have two chords here, and they intersect right here at point D. So I make 4 angles. 1, 2, 3, 4. So the most difficult thing about this is deciding which angles are they talking about. Well, look, they gave me this arc, and then they put a question mark here. So they want these angles right here. But remember, these two angles are vertical angles, so they are exactly the same, right? And they're intercepted arcs, right? So this angle here, the arc that it intercepts is this arc right here that's 90 degrees. And then this angle intercepts this arc here, JG, that is 70 degrees. So 90 and 70. I'm not going to subtract them like I did the other ones that were outside. I'm going to add them. So I'm going to add the big intercepted arc plus a small one. Then I'm going to still divide by 2. So it's the same exact thing, what we just learned, but you're going to add. So 90 plus 70 divided by 2. Go ahead and write that down and solve it and see what you get for the angle measure. Okay, so you should have added 90 plus 70, and that's 160 degrees divided by 2, and that's 80 degrees. So these angle measures right here, this angle here is 80 degrees, and its vertical angle is also 80 degrees. Okay, good job. Okay, let's try number 15. All right, so remember if they're created inside the circle, the angles created inside the circle, you're going to add the big intercepted arc plus the small intercepted arc, and you still divide by 2. So intercepted arcs. So I have 3 arcs, KL, that are measured, LA and JA. So they give me the measurements of 3 arcs. Which 2 are you going to use? Try number 15. So I'm going to, this is the angle they want. They want this because they have the question mark there. So that angle intercepts this arc, KL, and its vertical angle intercepts this arc, JA. So I am not going to use the 60 degrees. You're going to have 85 plus 65. So the best thing to do is figure out which one you're not going to use, cross it out, and then go ahead and solve it. Go ahead and try it. So they want to find this angle, and this is vertical pair. So add the 2, divide by 2. Okay, good. 85 degrees is this arc measure, degree measure, plus 65 degrees, this arc degree measure, divided by 2. You should have gotten 75 degrees. So the measure of the angles right here, this is 75. And this one over here is also 75 degrees. So we're going to practice 3 more problems real quick on the next page. But before we do that, let's go ahead and review finding this, the measure of this arc right here. Remember, the whole circle has to equal 360 degrees. So if you already have this arc that's 85, this LA is 60 degrees, and JA is 65. Can you guys find this one real quick? We did this last week. Remember, the degree measure all the way around the circle is 360 degrees. I already have 85 plus 60 degrees plus 65 plus how much more do I need? So 85 plus 65 plus 60 is 210. How much more do you need? So you're going to subtract from both sides. Solve that equation. Next, you subtract 210 from both sides. So you subtract from both sides, 210 from both sides. 360 minus 210 is 150. So then this arc right here would be 150 degrees, the degree measure of KJ, 150 degrees. Okay, try number 16. Find the measure of this angle and this angle. Okay, good. You should have done 29 plus 47 equals and divided by 2. That gives me the angle measure. Okay, you should have gotten 38 degrees. Good job. 29 plus 47 is 76 degrees. Divided by 2 would give you the 38 degrees. Okay, try number 15, please. Okay, this one is tricky because you have the 3 arcs, but which 2 do you need? Here's my angle that they're asking for. So that's this arc, 107. And its vertical angle intercepts this arc, which is 19. So those are the 2 you need. Go ahead and try that one. Okay, so let's try number 16 next. This is my angle they want to find. Here's its vertical angle. So these are my intercepted arcs, 71 degrees. And this one here, 129 degrees. So those are the 2 you would use. Go ahead and try number 16. Okay, so recap. If the lines intersect inside the circle, you're just going to add the 2 arcs and divide by 2. Okay, last page. What are the differences and similarities between the angles created outside the circle and the angles created inside the circle? Draw an example of each with the correct measurements. Feel free to use the sentence starters below. So if 2 lines intersect outside the circle, what does that look like? And then what do you do? If 2 chords intersect inside the circle, then what do you do? And what does that look like? So draw the 2 examples on your notes and then write, what do you do? Do you add? Do you subtract? Do you divide by 2, multiply by 2? What would you do? All right, we'll see you later. Bye, guys.